We're looking at carboxylic acids and its derivatives, and the main learning outcomes are draw the structures of carboxylic acids and know the reactions of carboxylic acids and describe a test for carboxylic acid. Let's look at the comparison between infrared spectroscopy for an alcohol. Alcohol will have one broad peak between 3200 and 3500 roughly cm per cm. Carboxylic acid will have two distinct peaks, the OH peak, which is much broader from 2500 to 3000, and of course the C double bond O peak. And the esters have a CO absorption peak, but it also has a CO peak, which we can look at later on. Carboxylic acids. The functional group for a carboxylic acid is C double bond O. Important that you familiarize yourself with the functional group. That's your functional group, COOH. It's carbonyl because of C double bond O. Naming: methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and so forth. Just a quick name for this compound here. Please note carbon 1, carbon 2, carbon 3, carbon 4, methyl on the fourth carbon. There are 5 carbons in the chain, 4-methyl pentanoic acid. Butanoic acid, again, if we look at this one, I'm hovering over, let me highlight it. Carbon 1, carbon 2, carbon 3, so it's propanoic, 2-methyl propanoic acid. Naming of these, let's name these. Again, carbon 1, you've got bromine on the second one, so 2-bromo propanoic acid. Next one, carbon 1, carbon 2, carbon 3, carbon 4. Carbon 4 is here. Carbon 1 is here. So 3-methyl butanoic acid. Physical properties, they are soluble in water because they form hydrogen bonds, and the solubility will decrease as the size of the carbon chain length increases. Okay, now you must be able to draw or show hydrogen bonding between a carboxylic acid and water. So let's look at the carbonyl group first. Oxygen or delta minus, lone pair. So dotted line from the lone pair on the oxygen in the carbonyl to the delta plus hydrogen in water. And you can do it the other way. You do need a the H. So this is the H in the carboxylic acid, delta plus, and dotted line to the lone pair of oxygen on water. So that's one way of showing hydrogen bonding in carboxylic acid. You can also show hydrogen bonds between two carboxylic acids or carboxylic acid by itself, and it forms something called a dimer. So just to have a look at the dimer formation. Okay, two acids also form hydrogen bonds, and we call these dimer. Solubility we've already mentioned. Melting point can be used. Melting point apparatus can be used to check the boiling points of, to check the melting points of carboxylic acids. This is a practical which needs to be done in school. So hopefully you will get the opportunity to do a practical of this nature. Right, reactions of carboxylic acids or preparation of carboxylic acids. There are 6 reactions or syntheses of carboxylic acid you need to be aware of. Oxidation of primary alcohol. Please note it's excess acidified dichromate. Oxidation of aldehydes. Hydrolysis of esters. Acyl chlorides reacting with water, which is a nucleophilic addition elimination reaction. Hydrolysis of a nitrile using HCl, dilute HCl, and also the hydrolysis of amides. All of these reactions are covered in A-level chemistry. So an example of oxidation of an aldehyde and an example of an oxidation of a primary alcohol. Okay. Carboxylic acids can also be prepared by hydrolysis of nitriles, water and HCl we're using, and it will form ammonium chloride as the second product. Nitrile is reflux with water and hydrochloric acid. Okay, carboxylic acids are weak acids, and they can undergo neutralization reaction, they can undergo nucleophilic substitution reaction, they can actually undergo nucleophilic addition elimination reaction, but it's beyond the scope of our syllabus. And they undergo esterification. So again, the esterification is actually a nucleophilic addition elimination, but you're not expected to know the mechanism. I would, however, learn it because I think it's an important one if the question is on application of mechanisms. Okay, so a very, very important reaction. Carboxylic acid donates or dissociates into a carboxylate ion RCOO- and it releases a hydrogen ion in solution. That's the reason why it's an acid, because it's a proton donor, H plus donor. The negative charge is delocalized around here, between this COO-, which results in a stable ion. Okay, so just as HCl reacts with sodium carbonate to form a salt, carbon dioxide and water, the salt formed here will be sodium ethanoate because it's ethanoic acid reacting with sodium carbonate, carbon dioxide and water. Basically here you really need to learn these reactions in order to answer the relevant questions in the exam. Methanoic acid reacting with sodium hydrogencarbonate, again sodium hydrogencarbonate will produce sodium methanoate as your salt, carbon dioxide and water. So you can see now the salt is named an OAte. Another example is with alkalis. So we'll get sodium propanoate plus water, because acid plus base gives you salt and water. So HCl plus sodium hydroxide will form sodium chloride and water. Here, because it's a carboxylic acid, if the carboxylic acid was methanoic acid, sodium methanoate. If it was butanoic acid, sodium butanoate. And the example of potassium butanoate is given below. With metals, again, remember when an acid reacts with metal, you get salt and hydrogen. Please note here, magnesium is a +2 ion. Carboxylate is a -1 ion. That's why you need 2 in brackets with magnesium. Here with aluminium, you will get CH3, CH2COO, this one, a bracket with 3, and H and Al swap, and you will get hydrogen formed as well. So you will get aluminium propanoate formed in this case here. Right, next one, with ammonia, you will get ammonium salt of the acid. So ammonium propanoate on this. Weak acids are carboxylic acids are weak acids, and they dissociate into salt and hydrogen ions. This reaction here is important to note, because the salt that is formed when a carboxylic acid dissociates can react with HCl to reform the carboxylic acid and sodium chloride. Okay, now that's carboxylic acids. Moving on to esters then. Esters are formed in a reaction between carboxylic acid and alcohol. That's what an ester is. Let's look at the naming of an ester. An ester is named it's named from the alcohol and the carboxylic acid it's made. So we will name this top one as methyl methanoate. So let's highlight this for you. This part here is carboxylic acid part. This part here to the right of this single oxygen is the alcohol part. So this carboxylic acid is made from methanol and methanoic acid. Your catalyst in this reaction is concentrated sulfuric acid, and you can read heat under reflux, and it's a core practical that will be done in year 13. Now let's name this one. That's methanol, that's ethanoic acid. So the alcohol we started with is methanol and ethanoic acid. So we will name this as methyl ethanoate. Okay, this one. If we look at this side, there's your methyl, and 1, 2, 3, 4, 5 carbons. So this is the carboxylic acid. So we will say methyl pentanoate, and the one below that methyl hexanoate. You can have others. I mean, the reaction, and now we will ethanoic acid reacts with ethanol. So the naming will be ethyl ethanoate, and water is liberated. This is why this reaction is also known as a condensation reaction. Concentrated sulfuric acid is your catalyst in this reaction, and the naming from the original is from the original alcohol and carboxylic acid. So if we had butanoic acid reacting with propanol, propan-1-ol, then we can name this as propyl butanoate. I believe that is correct. Esters are prepared from carboxylic acids. They can also be prepared from acyl chlorides and acid anhydrides, but acyl chlorides is a separate topic that we can teach later on. Okay, so I'm going to skip here. Hydrolysis of esters. Esters can be broken down into the carboxylic acid and alcohol they are made from. There are two types of hydrolysis. There is acid hydrolysis where HCl, and there is also base hydrolysis. And for base hydrolysis, you can use sodium hydroxide. So here, ethyl methanoate acid hydrolysis will form ethanol and methanoic acid. In the case of base hydrolysis, here, this is methyl ethanoate. So we will get, when this is hydrolyzed, it will form methanol and sodium ethanoate. So it will form the sodium salt, and this sodium salt can react with HCl to form the carboxylic acid, which we have discussed before. And you can pause the slide here just to see the reaction. Okay, right, next one. You can see now in this reaction the mechanism for base hydrolysis of an ester. The oxygen attracts a pair of electrons. The base attacks the delta plus carbon, or it's added. Then the oxide ion or the O minus ion reforms, and the CO bond breaks to form the carboxylic acid. The O minus R attacks the hydrogen and to form the carboxylate ion. This is just an example for you. This is a mechanism that not necessarily is not required at A level chemistry for AQA. Uses of esters: solvents, flavorings, plasticizers, and esters are used in the industry of making creams, water-based creams, to prevent skin from drying up. What about the role of propane 1,2-triol, glycerol? So vegetable oils and animal fats. Vegetable oils and animal fats are esters of propane 1,2,3 triol. Basically, long chain carboxylic acids are called fatty acids, which contain around 12 to 18 carbons. Glycerol is propane 1,2,3 triol. So you can see now it's got 3 carbons and 3 hydroxyl groups attached. Okay, so the key reaction is formation of vegetable oils and animal fats, which we also call triglycerides. So we've got a fatty acid. R1 can be 17 carbons, 18 carbons. The reaction is very similar to esterification, and it forms what we call a triester or a triglyceride. And in each case, the glycerol loses this hydrogen, and then the carboxylic acid can lose this hydrogen with its OH, so loss of OH there, and then bring the two molecules together, you get the product that's there. Propane 1,2,3 triol has 3 OH groups, so it's really soluble in water, forms hydrogen bonds. It's used as a solvent in medicines and toothpaste, and please note it's used in cosmetic preparations because it prevents the ointments from drying out. Vegetable oils and animal fats continued. How do we make soap? Easily, you take a triglyceride, which we've already formed from the earlier slide, heat that with sodium hydroxide. The triglyceride will be hydrolyzed. You could just say the breakage happens here. So this CO bond here breaks. The glyceride reforms, and you get a sodium salt of the triglyceride, which actually is your salt, sodium stearate or something like that. Secondly, you also need to know how to make biodiesel. Biodiesel is simply made by vegetable oil, heating that with methanol. Again, it's like a hydrolysis reaction where the CO bond here, I'm highlighting it here. It's let me just change the color of the pen color here to something like blue, I think. And you can see this break here. That breaks, forms propane 1,2,3 triol, and then the RCO and the methanol attaches here to form your biodiesel, which is a green fuel, and it's biodegradable. And that's it really for the topic of esters and carboxylic acids. It was a quick overview of the topic, and hopefully you would spend much more time in school going over this. Thank you.